Okay, let's look at the solutions to practice SAC and also some reasons why some of these other answers are incorrect. First of all, implied domain for the function. So all we need to do, show a bit of working, is substitute the given angle, which is 2x, between -1 and 1. That obviously leaves us negative half to half inclusive, so D is the correct answer. Automatically go to A and mark that off as incorrect because it's not inclusive. And that's all you need to say. Say the domain is not inclusive. 0 to pi, the reason that is incorrect is that that is actually the initial range. So that's why that's been rejected. -1 to 1 is rejected because that's initial domain, all right, without any transformations. And then 4 minus 3 pi, if you have a look at this, you can see the 4 and the 3 here. So what they've probably done is substituted 0 to pi and calculated the range. So that's all we'd say. All right, range has been calculated. Question 2. Cos x, x pi and 3 pi and 2. So what do we do here? We draw our triangle. Our triangle is in the third quadrant. We're talking cos, so adjacent over hypotenuse, 7 on 25. That's negative, missing values 24, negative 24 on 25, there's x. So first thing I would do is reject e. E is actually the value of sine x. Who knows why they did it, but that's what they've done. They've voted the value of sine x. Actually do the working. As soon as you want cos x on 2, we use the cos x equals 2 cos squared x on 2 minus 1 formula. All right, double angle formula. Cos x is negative 7 on 25. We add 1 to both sides. That gives you 18 on 25 is 2 cos squared x on 2. All right, divide by 2. Therefore, over the other side, we get cos squared x on 2 is 9 on 25. Cos x on 2 is the square root of that, so it's plus or minus 3 over 5. So that means one of these answers would be rejected automatically, and one will be the correct answer. Back to the domain, and we've talked about this 1,000 times, and no one is to get this wrong in the SAC. Angle x is in the third quadrant. I don't care about the third quadrant. I'm looking for x on 2, which is therefore dividing both of these by 2 places us in the second quadrant. In the second quadrant, cos is negative. Therefore, B is rejected for incorrect quadrant. All right. And A is rejected. It's just got the incorrect signs. They've probably drawn the triangle and just got 24 on 25, so we'd have rejected that for that case. And 4 on 25, I would simply reject. There's some incorrect mathematics there. I think if you use the sine rule, you'll find that you get 4 on 5. Question 3. Range. To do the range, what you do to the word, you do to the range. So the range for a normal sine function is from negative pi on 2 to pi on 2. Right. And therefore, if we expand that, you'll get 5 minus pi, and you'll get 5 plus pi inclusive. So B is the correct response. A is a reject. That is the initial range without any transformation. Negative third to third. What they've done here is work out the actual domain. So that's the domain of the function. Okay. Negative pi on 2 plus 5. Negative 1 pi on 2 plus 5. They've ignored the 2 here. Right. So what they've done is transform it just by 5. And this transformation is just multiplied by 2. So in this one, they've forgotten to multiply by 2. In this one, they've forgotten to add 5. And that's the rejection of those next two values. Okay, graphing. With this function, sorry. Looking at this, Probably the best way to work this out is have a look at what the implied range and domain is. First of all, because we've got a domain from -3 to -1, that satisfies all 5 brackets, x plus 2. So then what we're looking at is we need to have a range that goes from 0 to -2 pi. Right. So by process of elimination, we work out each individual range. So remember, for a normal cos function, it is 0 to pi. So 2 times 0 to pi is rejected, and that's your explanation. You can actually just show the working. This would become negative of 0 to pi. If we looked at the range, again, that would be rejected. This, the normal range, would be negative pi on 2 to pi on 2. And if we took away pi on 2, that would get us negative pi to 0, rejected. Negative 2 times 0 to pi becomes 0 to -2 pi, which is acceptable. That's the answer. And again, I would show this one by rejecting negative pi on 2, take away 3 pi on 2, and that gives us -2 pi and -pi. So again, that is rejected. So you can reject it simply by showing the working to make it incorrect. The value of inverse cos sine of negative pi on 3 is actually asking you to work out the value of inverse cos. Now sine of negative pi on 3 puts me in the 4th quadrant. Sine of pi on 3, sine of 60 is root 3 on 2, and therefore negative. Okay. So our base angle, when does cos equal root 3 on 2? The angle is pi on 6. Alright, so reject that because that's simply just the angle. Reject D because they've taken the angle of pi on 6 in the 4th quadrant, but cos is not negative in the 4th quadrant. Cos is negative in the 2nd quadrant only, so therefore 5 pi on 6 is the correct answer. And these two I would reject automatically, simply saying they got the angle wrong. They've thought of cos of 3 on 2 as pi on 3 instead of pi on 6. Right. Graphing. Again, rejecting. I'd go through quickly in a question like this, and because you see that A and its inverse are not at the same point, and the value of C and its inverse are not at the same point, that means that anything that says A equals -1 or C equals -1 is rejected. So we reject A, we reject B, and we reject D, all for similar reasons. And that is the reciprocal, if they were worth -1, the reciprocal and the graph would intersect at the same point. If you then look at the other values, we're left with, both of them say C is less than -1, so things like -2, etc. And if you reciprocate -2, you'd get -0.5, and so that makes sense for both of those. And the similar thing looking at the value here, A. If A is less than -1, such a value as -3, -4, the reciprocal would be -1/3 or -1/4. So E is the correct answer, and C is rejected because if A was greater than -1, you would expect the graph and the reciprocal to cross each other. Values of A, H, B, etc. Okay, first thing to realise is that now the centre point is 1, 1. So it's in the form of x minus h and y minus k. So it's in the form of x minus 1 squared and y minus 1 squared. Okay, so the centre 1, 1 means that h and k have values 1, 1. So we reject D and E automatically because they've got the incorrect centres. A, B and C have the correct centres. We now move to the next point of thing. Having a look at my semi-major axes, I've gone from 1 to 5, so A is 4. So if A is 4, that becomes 16. But we're asking for the question of A, so we reject that because it's 16 and 9. We're now dealing with B and C. It tells you semi-major is 4, therefore the correct answer is C. and B is incorrect because they've mistaken the semi-major and semi-minor axes. So you'd make some comment about that. Addition of ordinates. Right, we're going to see what gets rejected on this function. Having a look at the truth value, with a question like this, I'd be explaining what is true. Alright, so the domain is from A to D. Obviously, both functions start at A and finish at D, so that is correct. It says there'll be an x-intercept between x is 0 and x is b. That is also correct because at x equals 0, one value is e and one value is the direct opposite negative e. So if you add them together, they would actually give you 0. At c, f and x and g of x are both positive. So if you add them together, they have to be more positive than they are at e. That's true. At x equals a, we have a small negative and then a larger positive value. So if I put these two together, the positives are going to win. Therefore, this is incorrect. That's the answer we want. And at x equals d, again, both positive values, therefore the sum must be positive. And that's what we say. So we prove them by truth rather than seeing what mistakes students make. Something like question 9, alright, we need to state the asymptotes. Work out, first of all, when this function equals 0, 1 minus 3x equals 0, we get x equals a third. And this whole function is remaining, so you get y equals 2x squared minus 3. As my other asymptote, b is the correct response. You then explain what's been rejected by everything else. Right. In A, they've ignored the variable. They just think that it has to be a whole number asymptote. That's what's wrong there. In C, they've done the old-fashioned change the signs and assumed that this whole value is 1, so it gets rejected. In D, they've got the maths incorrect, and when solving that equation, they've got x is negative a third, rejected. And in E, the misconception there is that it's only the variable that becomes the non-vertical asymptote, so they've only quoted the 2x squared. So, rejected again. Messed up to try and get all these solutions into that. Okay, understanding about asymptote. We're doing g of x minus f of x. So what I would first of all do is turn f of x upside down. So you can write that as g of x plus negative f of x. It's always easier to add ordinates than it is to subtract ordinates. So we have a function like that, and then we have negative f of x like this. And you're going to add the two together. Obviously, that's still so the first one's wrong because y equals 0 is fine, but x equals 0. Sorry, x is 0 is an asymptote, but y equals 0 is no longer an asymptote, rejected. This one's rejected because there are actually two asymptotes. There's an asymptote through here, and then there's an asymptote like this. So negative fx and x is 0 is the asymptote. Reject this because they've ignored the fact that x is 0. Reject this because they're actually still saying that that's an asymptote up there. So they haven't actually done subtraction of ordinates. And g of x is rejected. That's ridiculous. That will never be an asymptote anyway. So quite silly answers actually. Alright, subsets. This needs to be known that it's z minus the centre coordinates, magnitude, equals the radius. Okay, when it's in this form, that point there is the centre and the answer at the end is the radius. So we wish to have a centre that's 1 minus I. So reject, reject, reject. And all three can be rejected simply because they've said the wrong centres. Okay. According to this, the centre should be 1 minus I and the radius should be 16, so there's the correct response. and A is rejected because they have thought that this value represents r squared when actually it represents r. So we would explain something about saying thought this was radius squared. So that's the rejection of 11. Bring us home with the complex number questions. Okay. First thing we do, alright, let's write it in our normal way. So that's actually negative 2 root 3 because we've moved it across that way, and negative 2 in the I direction. So we can reject A and E automatically, saying they got the signs wrong. Then we'd work out our R value for this function. Now R value, if we square that, 4 3's 12 and 4 16, square root R equals 4, so I would reject B, they've got the incorrect magnitude, as soon as you've shown that working. Then when we do tan, we're in the third quadrant, and we have negative 2 over negative 2 root 3, so it's 1 on root 3 for tan, which means my base angle is pi on 6, but I'm in the third quadrant, so if I walk around like that, I must actually get negative 5 pi on 6. And I would reject that reject that answer, sorry, because we're in the wrong quadrant, and simply that's what you'd state, wrong quadrant. 13, Z on W. So Z on W, work out that is 6 divided by 9. You divide the R values. Cis, negative pi on 3, take away 3 pi on 4. So that's going to give me 2/3 cis. So that's negative 4 on 12, take away 9 on 12. So what's that? Negative 13 pi on 12. Which means we get 2/3 cis. Now negative 13 on 12 is great, it's more than halfway, so that's equivalent. Right, so negative 13 on 12 is like this, you've gone into there, so that's equivalent to 11 pi on 12. Right? D is the correct response. Right. A, wrong, because number one, they've divided W by Z instead of Z by W. Don't even worry about the angle. B, wrong. They've multiplied the two values. C, wrong, because they've assumed that negative 13 on 12 is negative pi on 12. They haven't gone the right way. And E, I don't even know where they got that 3 from. Chances are they subtracted the angles. Subtracted the magnitudes, so wrong for that case. Right. Z to the negative 3/4. That means we've got 16 to the negative 3/4. Cis, negative 3/4 times pi. So 16 to the negative 3/4. 16, the fourth root of 16 is 2. 2 to the negative 3 is 1 over 2 cubed. So the answer should be 1 on 8. Cis, negative 3 pi on 4. Right, 1 on 8, cis, negative 3 pi on 4. So then we start rejecting things. A, rejected, because to get negative 12, they've multiplied 16 times negative 3 on 4. So that's rejected. B is rejected. Negative 8, what they've done is 2 to the negative 3. They've presumed that that's negative 8. Stupid. C, correct answer, which we've had. D, rejected, because negative 3 pi on 4 they've written at 5 pi on 4, which is not within the normal acceptable range. And then they've messed up E, and they've taken the fourth root of 8. So they've ignored the 3. Well, don't know what they've done. They've square rooted, messed up the magnitude completely. So you just say the magnitude is incorrect. And last of all, Z4. First thing I would do is look at this and reject C, because they know that on complex solutions there has to be 4 answers. Okay, we can do this a couple of ways. If we do Demois's theorem, maybe we wouldn't. Why don't we turn around and do difference of 2 squares? So it's Z squared minus 3 or minus 9 squared. Right, z4 minus 9 squared is 0. That gives me z squared minus 9 and z squared plus 9. That gives me z plus 3 and z minus 3 and z plus 3i and z minus 3i. Okay, so therefore our solutions are plus or minus 3 and plus or minus 3i. So I would reject B automatically because they've square rooted the 3 once again. So we've got that wrong. We then need to look at these three answers. Now first of all, you need to know that answers need to be equally spread apart. So 3, 3 pi and 3 pi and 2. I'd reject that one straight away because 3 cis pi and negative 3 are actually the same thing. So we don't have four different solutions. So we're talking about one of these. So this goes 0, pi, negative pi and 2 pi. 0 and 2 pi are the same. Pi and negative pi are the same. So reject A. So it has to be D. So you actually could get the answer without even solving the question, without even doing this working. You could reject them based on logic and the knowledge that whenever you have fourth roots, they have to be equally spread out 90 degrees apart. It doesn't matter what their orientation is. In our case here, the orientation is straightforward. So therefore D is the answer. But that's the key point to realise. Equally spread out, rejected, rejected and rejected simply because they're not equally spread out. Okay, done.